I'm making this video for those of you that have problems seeing the presentation on the webcam. So hopefully this works out for you. Plus you can rewatch it if you were in the classroom or if you watched it on YouTube. So this is 2.1, inductive reasoning and conjecture. By the end of it, the plan is that you guys will be able to use inductive reasoning to make some conjectures. You'll see what that means, and to find counter examples and be able to prove when something's not true. And I'll show you what that means too. So this is all the vocabulary. You can pause the slide and you can write this all down into your notes. I'm going to go quickly through it to make the video not be too long. So inductive reasoning is when you make a rule from what you see, pretty much is what it means. So if you're looking at a few examples and you start noticing a pattern and you think you know what's going to happen next, you're doing inductive reasoning. A conjecture is when you make a rule out of that. So once you've done that inductive reasoning, actually trying to form a rule in your head, that's a conjecture. What that rule that you're creating is the conjecture. A conditional statement is a way to format those conjectures so that you have a hypothesis and a conclusion. And if you think about science class, you have your hypothesis at the beginning of the experiment. And if you think about your English class, conclusion goes at the end of the experiment. So the way that an if-then statement is written, the first piece of it is your hypothesis, and the last part of it is your conclusion. And it's called an if-then statement sometimes instead of conditional, because that's the order that they go in. If is your hypothesis, then is your conclusion. So there's a note right here. We're going to see more about this later on. A conditional statement could be true or false. So you can't just trust that they always work. You always want to test them and see for sure, do they work? And the converse is going to be where you flip them around. So if you think about converse like the shoes, think about the shoe on the wrong foot. You'll see that in the examples following in the other slides. So another vocabulary term is counterexample. And a counterexample is the way to show that something doesn't actually work. So like if I say all math teachers are male, a counterexample could be Ms. Higgins, Ms. Moreno, Ms. Fuzi. There's a lot of counter examples that show that what I just said was false. So if you can find one counter example, then that works. Now, you still have to have this part in red. The hypothesis has to be true. So if you remember the names that I called out, they were all female, but they were still the math teachers. So my hypothesis of math teacher was true. It was the conclusion that was false. They were not male. Deductive reasoning is when your conclusion is based on previous rules, pretty much. So if you already know about the segment addition postulate and you use that to make a new rule, a new theorem, you're using deductive reasoning. Remember, inductive reasoning was where you were looking at the examples and trying to figure out a rule or a pattern from what you see. Deductive, you're using rules or theorems, postulates, definitions to make new rules out of them. So you're gonna have to pause the video on this one so I don't have to make this video too long. But if you're looking at the next numbers, 5, 10, 15, 20, 25, 30, hopefully you'll be able to find out what the next number would be. So pause it right now if you need more time. The answer is 35. The next one will be 40. The next one will be 45. When you do this, being able to figure out like what number comes next, that's inductive reasoning. So you've already probably done this before, but sometimes it's easy and sometimes it's more difficult. And what we need to do is get you enough practice so that it becomes easier on the more complicated problems. So if we tried this one, you can pause the video. The next three numbers after 7, 9, 11, and 13 would be 15, 17, and 19. And what you did, hopefully, in your brain was you looked at the numbers and said, okay, it looks like they're going by 2. So every single time from 7 to 9, you add 2 to get to 9. 9 plus 2, you get 11. 11 plus 2, you get 13. So the next one would be 13 plus 2, 15. 15 plus 2, 17. 17 plus 2, 19. Just like up here. These went by 5s, so you added 5, added 5, added 5, added 5, added 5. So you keep on adding 5. Okay, now, this is where it starts getting a little bit more complicated, but it makes it more interesting. So if you're looking at these, you can pause the video and find out what you think the next one would be, figure out what's going on here. So the next number is 48, and the way that I got that was I got from 3 to 6, the difference was 3, but then from 6 to 12, it wasn't 3 anymore. But then I saw, well, 3 times 2 makes 6, and then I tried that pattern out. 6 times 2 makes 12. 12 times 2 makes 24. So that's how I know that it's this number times 2 to get my next number, 48. So on this one, try it out. Pause the video if you need to. Okay, so on this one, the numbers are getting smaller. You're obviously not adding. From 256 to 128, the difference is 128. So the difference from 128 to the next 164 isn't the same thing. We're not subtracting. So then we try dividing. Okay, 256 divided by 128. The difference here is 2. So that means 256 divided by 2 got me to this number. 128 divided by 2 got me to this number. So I'm going to keep dividing by 2. So the next number is 32. So like I said, if you need to pause the video, you can pause it to write these into your notes. Next idea is conjectures. So remember, the conjecture is when you're making a rule going by what you see. So if I give you part of a conjecture and say the sum of 2 odd numbers is, and then you need to find out what's supposed to be the last piece of this, you go, okay, let me write some examples down. So you go, well, 5 plus 3, those are 2 odd numbers. Sum means you're adding them, so I added 2 odd numbers. I come out with an 8. Then I do it again. I find 2 more odd numbers, 9 and 5, 14. 2 more numbers. It didn't say I couldn't use negative odd numbers, so I'm going to put one of those in there to make sure I have enough variety in my examples. So negative 7 plus 11 is 4. And then if I try 2 negative numbers, they're still odd, but they're negative. I get negative 6. And now I'm going to look in here on the right side, and I see 8, 14, 4, and negative 6. And I try to find out what do they have in common. And if you're looking at that, you go, well, they're all even numbers. That's going to be what you put in the end of the conjecture. So you're going by the observation, and if I don't give you examples, you can make your own. And you're going to want to make sure that you keep this part true. Sum means add 2 odd numbers. So you don't want to use like 2, 4, 6, 8, 10. Those are even. You need to use odd numbers, and it needs to be adding them together. And make sure that you cover all of those little intricacies, like, oh, it could be negative, because sometimes that's where mistakes happen. So be careful with that. So here's another one. Try it out. Pause the video. Give yourself some examples, and then see if you can come up with a conjecture on this thing. Okay, hopefully you tried at least a few examples, not just one, to come up with your conjecture. So I went ahead and went with 5 and 3. Those are odd numbers. Product meant you're multiplying. And then I picked 9 and 1. And I picked negative 7 and 11. So those are all odd numbers. Notice I'm still covering the negative side of this because it could be negative. And then 2 negatives. On this one, I decided to try the same number to see if that did anything. And I look over here on the right side. Everything that I'm getting here, 15, 9, negative 77, negative 25, there's positive and there's negative, but every single one of them is odd. Okay, here's another one. The conjecture, the sum of three odd numbers is positive. Now we're doing the counter examples. So counter example is where you're trying to basically break the rule. You're trying to make it so that it doesn't work. You want to show that, oh no, this isn't right. So the sum of three odd numbers is positive. Get three odd numbers and then try to see if you can make it not be positive. So you want to keep this part true for a counter example. The sum of three odd numbers, we want that to stay true, and we only want this last part to be false. So we want to add three odd numbers, like 5, 3, and 1, like 9, 5, and 3, 7, 11, and 1. Those are all odd numbers, and I'm adding them. That's sum. Again, I cover my negative bases. And notice that in the beginning, it was working out. These were odd numbers. It was positive. Odd numbers, positive. Odd numbers, positive. Looks good. But by doing enough of these examples, I found one that broke the rule. Because these are odd numbers. They're negative, but they're still odd. And I came out with a negative number instead of a positive number. So that means that this line right here is my counter example. If I was asking you to write a counter example, you would write this whole thing. You'd put -5 plus -3 plus -1 equals -9. And you might want to circle or highlight the -9 to show that is the part that is breaking the rule. So that's how counter examples work out. You just try to find one example where you break the rule. Then we have our conditional statements. That's that if-then part. They're very, the word's formulaic, like they're very, you just plug in the things where they go. If is always in the beginning. There's always a comma then, and then you have your hypothesis after the word if, your conclusion after the word then. So on this, I put hypothesis in red and my conclusion in blue right here. Notice that the hypothesis doesn't include the word if. Conclusion does not include the comma or the then. So if I ask you to put an underline on the hypothesis, make sure you do not underline if, start with A, and then number is even, and then stop before the comma. When I ask you for the conclusion, make sure that you put it not with the word then, start after that, and then go all the way to the end of the sentence. That's going to be your conclusion. So for conditional statements, if I'm asking you what is the hypothesis and the conclusion, be very careful about where you underline or where you circle or where you double underline to not include the word if or not include the word then, because those are just like the markers that tell you where it starts. It's not actually part of the hypothesis. It just tells you where the hypothesis is gonna begin. It's not part of the conclusion. It's where the conclusion is gonna begin. And then we have our converse. Converse, remember, that's like the shoes on the wrong foot. So a converse is going to get this conclusion and it's going to make it a hypothesis. It's going to get this hypothesis. It's going to make it the conclusion. So the part about the number being divided by 2, it's over here now in the hypothesis. The part about a number being even, that became the conclusion. So you get the original conditional statement and then you put the shoe on the wrong foot. You flip it around. So they trade places. The hypothesis and conclusion trade places. That's how you write a converse. Try this one out. Try to write yourself the converse, because you know that's what I'm going to be asking for. Remember the hypothesis and the conclusion, and go ahead and try to write your converse. Pause the video because it's going to take you a bit to write it, and then unpause it when you're ready. So if you wrote the converse, you started with a number being multiplied by 3 in the beginning. So if a number is a multiple of 3, that's in the beginning. And then the second part is your conclusion. It came from over here. A number is a multiple of 6. A number, we're talking about it, is a multiple of 6. So the part about the, what is it in English? The subject, I think. That part, remember that in the beginning of the sentence, you're going to want to put what you are talking about, and afterwards you can use it. That's still true here. So a number stays a number. I didn't put it in the beginning. There you go. Now watch out. Notice the note at the bottom. I don't know if anybody even paid attention to this part. If a number, let's start it here. If a number is a multiple of 6, then it is a multiple of 3. So that means that multiples of 6 would be like 6, 12, 18, 24. If you take any of those numbers, 6, 12, 18, 24, you can keep going with it. You can always divide those by 3. This original conditional statement, it's true. There's no counter example for this one. But on the bottom, there's that note that says sometimes your conditional statement, when you make a converse, the converse isn't true. So on here, read through the converse, see if it works. If a number is a multiple of 3, that would be 3, 6, 9, 12, 15, etc. Then it is a multiple of 6. Well, 6 works, and 12 works, and 18 works, but then there was the multiple of 3 like 9. 9 is not a multiple of 6. So even though the original conditional statement was true, we still have to double check our converse to see if it's also true. Sometimes it is, sometimes it isn't. If I go back to the previous slide, a number can be divided by 2, then the number is even. That's still true. If you can divide any number by 2, that is an even number. But if you look on the second example, go forwards. Now the conditional statement originally worked, but the converse did not. So always double check your converse, even if you already checked your conditional. That does not mean your converse is gonna work. Okay, so the assignment is inside the Google Classroom. If you already watched this presentation before, you know this, but if you're watching it for the first time, it is in the Google Classroom. It's assignment number 16. It's 2.1, which is what today's lesson is. So make sure that when you finish that assignment, send it through a picture or PDF through the Google Classroom. We're not using Remind anymore. And then make sure that you submit it through the assignment number 16. So that way it goes into the right spot.